Hello friends, today's topic is SQS, Simple Queue Service. SQS is one of the messaging service of AWS. Today we will be seeing why and what SQS is and the benefits of SQ, and then we will see what standard and FIFO queue is. So let's start. Before we start, let's try to understand what synchronous and asynchronous process is. Here you can see there are two components, one is producer and another is consumer. Producer job is to push the message to the consumer and consumer job is to process the message. Both are directly connected. However, if one of the component is down, your entire system is down. So the pros of this process is that simple design and easy to understand. And the cons of this process is that it is not easily scalable and it is not loosely coupled. I'll try to explain what not loosely coupled means in asynchronous process. Let's understand what asynchronous process is. Here you can see one more component in between producer and consumer, that is message queue. Here producer job is to push the message to the message queue and consumer job is to process the message from the message queue. So loosely coupled means if one of the component, let's say if producer is down, so consumer is still be able to process the message from the message queue. Same way, if consumer is down, producer is still be able to push the message to the message queue. And other pros of this process is that it is easily scalable, means we can place multiple producer that can push the message to the message queue, and we can place multiple consumer that will process the message from the message queue. If one of the consumer is down, the other consumer can process that message. So this process is to handle the large workload. And the cons of this process is that more complex and the communication is over the network. However, in synchronous process, the components are directly connected. So let's move forward. SQS offers two types of queue. One is standard queue and other is FIFO queue. So let's understand what AWS standard queue is. Here we have taken two producer and two consumer, and let's assume producer 1 and producer 2 has sent three messages M1, M2, M3 to the queue, and consumer 1 has picked up the message M1 from the queue. So now SQS will lock the message M1 and M1 will not be visible to the other consumer until the visibility timeout period expires. So let me define what visibility timeout period is, and let's say we have defined that visibility timeout period is 30 minutes. So that means consumer 1 has to process the message and delete the message from the queue within that 30-minute time period. Okay. If consumer 1 is not able to delete the message from the queue within that visibility timeout period, then SQS will unlock the message so that it will be visible to other consumer and other consumer can start processing on it. And let's assume that consumer 2 is also not able to process and delete the message from the queue within that visibility timeout period. So again, SQS will unlock it so that other consumer number 3 can start processing on it. So here comes the dead letter queue. For this type of scenarios, we can define dead letter queue. So dead letter queue is to hold the fail message which are not able to process by consumer after specified number of counts. So dead letter queue is to hold the message that can't be processed, right? So let's say we can define that after 3 number of counts, if the messages are not able to be processed by any of the consumer after 3 number of count, it will move to the separate queue, which is dead letter queue. So SQS is pole based, and whereas SNS is event based, means if any message arrives in SNS queue, then it's the SNS job to push the message to the subscriber. However, in case of SQS, if any message arrives in SQS, it's the consumer job to pull the message from the SQS queue. And the maximum size of the message can be up to 256 KB. Retention period means that message can live up to 14 days in the queue. Okay, short polling and long polling. Okay, so that means actually AWS charge us on request basis. If consumer keeps polling, so we will be charged per request basis, and there would be a chances that the queue is empty. So we don't want frequent or continuous polling, right? So we can define the time. 20 seconds is the maximum time we can define. That means if there is a message in queue, the consumer will process it. Or if the queue is empty, the consumer will wait up to 20 seconds. I will show you this also in demo. So that's it. So let's move to SQS FIFO queue. So SQS FIFO queue, first difference is that the type of the queue is .FIFO. So you can give any name like demo, and the name would be demo.FIFO queue. Second difference is that standard queue is not follow the exact order. Processing order could be different. Messages are processed in a different order from which they are sent. Okay. However, in FIFO queue, order is preserved, means in exact order that they were sent. I'll explain this part in demo also. Okay. Second difference, you can see there are two boxes inside the box in queue, that message group 1 and message group 2. Means producer 1 is sending messages M1, M2, M3. These messages are associated with one group ID, and other producer is sending message M4, M5, M6. These messages are associated with other group ID, message group 2. Okay, so this is like just, so within the message group the order is preserved. So it is like that you go to a restaurant and the person who is serving you, he will follow the order. Like he will first serve you the starter, and he will then serve you the main course, or he will then serve you the dessert, right? So the other family sitting on next table in same restaurant, the other service guy will follow the same order to them also, right? So this is exactly the same in FIFO queue. So message in message group are processed sequentially. Okay. However, message in other group can be processed parallelly, right? This is the second difference. Now let's understand the third difference. In standard queue, whenever consumer pick the messages, so SQS will log that message only. However, in case of FIFO queue, if consumer 1 has picked up the message M1, in this case FIFO queue will log the message group, so that M2 and M3 messages won't be visible to consumer 2. Okay, so until the visibility timeout period expires. So if consumer is able to delete the message within the visibility timeout period, then SQS will unlock the message group, and M2 and M3 will be visible to other consumer also, and any consumer can start working on it, right? In case of consumer 1 is not able to delete it within that visibility timeout period, then again SQS will unlock the message group, and M1 will be visible to other consumers, so that other consumer can work on it, right? So I hope I have cleared all the things for this topic. That's it, guys, for today's. If you have any doubts, then don't worry, we will clear all doubts in demo part. If you like the video, please hit the like button and subscribe my channel. Thank you.